Exponential functions, graphs. So to graph an exponential function, you can plot points to find ordered pairs on the graph. Example 1. You donate $5 to a cause you care about. Then you challenge 5 of your friends to donate $5 to the same cause. Then those friends challenge 5 of their friends to do the same. Assume that it continues at the same rate, so it can be represented as y equals to 5 to the x. Now, graph y equals 5 to the x. Now, right, this is exponential. Why do we know this? It's because 5 is our base, right? And x is our exponent. So therefore, since our variable is in the exponent, it's exponential. So let's find some points to plot. So if x equals 1, this means y equals 5 to the 1, which is just 5. Now, what happens? Also, this is also good to know. If y equals 5 raised to the 0 power, what's that? Well, that's a 1. So it's also good to know. So let's look at y when x equals 5 raised to the second power. Well, that's 25, because 5 times 5 is 25. Now, what happens when y equals to the fifth power? Well, let's get our calculators out. So I'm just going to use our free calculator that's on the computer. Feel free to type in scientific calculator on Google and find one there. You're welcome to borrow one from the STEM Center. But so it's a little bit trickier to find certain things to each calculator. But so on this one, well, we're going to just go 5. We see this right here. So x raised to the y power. So we're going to type in what y is, because now it gives us that caret. Sometimes you'll see that caret in the calculator. That will be your exponent. So I was trying to tell you that. So 5 raised to the fifth power. Well, that's 3,125. What happens when we raise it to the 10th power? Well, we're going to get pretty large here. So we get 9,765,625. So you can see why this is exponential, right? Going just from 1 to 10, how big of a gap that is. Or range, however you want to say it. Now, we're going to go ahead and start graphing some points. So what we're actually going to do is we're actually going to use this, right? Let's look at 0 and 1. Let's look at 1 and 5. And 2 and 25. Because we can see pretty well from that. So we're going to go 5, 10, 15, 20, 25. So I just decided to use that. Most times you'll have a smaller number, so you don't have to do like this. Or just because this is a really large number here, that's why. Okay, so if we have this, so let's look at 0, 1. Well, 0, 1 is going to be somewhere like right there. Right? Maybe a little bit down a little bit. But then we have 1 and 5. So we have that. Then we have 2 and 25. So 2 and 25. And right 5, and then 125 is going to be way off this screen here. But we can see, right, if we were to connect the dots, it's just going to continue on. And then if you were to draw like this, it's going to continue on that way. It's going to get really small. Because what's -1, well, that would be 1 over 5. So we get really small that way too. Let me go the opposite direction. But the point is to show that this is exponential. Now, since we're going left to right and when we're increasing, this is going to be positive, right? So this shows growth, right? Because we're going up. So before we go on, let's think about what we just did here. So this first time right here, right? That's you. You gave $5. So the cause got $5. Next time you challenge 5 of your friends. So 5 of your friends donated $5. So that's $25. Then if there was on the next, and those 25 friends, right? If we did 3, then that'd be $125 because 25 all donated $5. So that's $125 just for that round, right? That's not cumulative. We're not adding up everything before that, right? And you can continue on, right? And if when those 125 then don't ask their 5 friends, like what's that number, right? It just continues to get so large. And this is why it's like, right, it's just exponential. So this graph, when these points are, it's just to tell you at that time when you have, right, like say your 5 friends donate $5. Well, that's the $25. The next one would be 125, and right, and so forth. So that's just how to kind of connect this thought and why it can get so large, because it's just exponential growth rather than linear. Now let's go look at another example. Example 2. When evaluating exponential functions, remember we're going to use order of operations. So why is that important? Well, so we get the right points, right, when we graph this. So let's look at this. We have graph y equals 10, and then in parentheses 2 raised to the exponent of x. So if we have x is -1, what does that mean? Well, let's go ahead and put in -1 there. Well, that means we need to simplify everything within the parentheses first. So let's go do that. So 2 raised to the -1. Well, all we can just do is go ahead and put it in the bottom, and now it's just raised to the first power like that, because now it's not negative this way. So what's that? 1/2? Well, that's just 5. So that's 5. Now we have 0. So y equals 10, 2 raised to the 0 power. So now we get 10. 2 raised to the 0 power is actually 1, right? Anything raised to the 0 power is 1. So that's 10. Now y equals 10, 2 raised to the first power. Well, we need to simplify everything in the parentheses first. So that's just 10. 2 raised to the first power is just 2. So then 10 times 2 is 20. Now let's look at this last one, 10, and then 2 raised to the second power. So that's 10. 2 raised to the second power is 4. 4 times 10 is 40. Notice all we're doing is just we're doubling every time we increase in 1 on the x side. So that would be exponential. We're getting, as x increases, y increases, so we're going to have a growth, right? Like the positive exponential graph. Mostly we can say that because, right, it's going to have a trend like that. So let's go ahead and graph this, because our points are -1 and 5, 0 and 10, 1 and 20, 2 and 40. So I'm just going to go actually in. So the first one is -1 and 5. Well, that's going to be somewhere midpoint there. And let's change the color here. Now we have 0 and 10. So 0, 10, which is right there. And then we have 1 and 20. And then 2 and 40. Right, and so those are the points. We're just going to connect them. We're going to draw an arrow. Draw an arrow. So that would be our graph.